Hello, grade 12 students. In this video, I'm going to revise the important concept that we have already taken throughout the previous 2 weeks. So first of all, I'm going to start with the limits. You know that the limits of a function are the values that indicate where does the function approach as it inputs approaches negative infinity or plus infinity or even a number, okay? So first of all, as we said, the limits of a function are the values that the function approaches as its input approaches negative infinity, or even the limit at a point. For example, a limit of 3 over x when x tends to plus infinity, you replace the x by infinity. Number over infinity, 3 over plus infinity is 0 plus. So number over infinity is 0. Now, limit when x tends to 0 plus, it's 1 over 0 plus. So 1 over 0 plus, number over 0 is infinity. What infinity? It's plus infinity because we have positive values. So let us remember together that number over infinity is 0 and number over 0 is infinity. Of course, plus or minus infinity, it depends on the value itself, if it's positive or negative. Sometimes when we are doing the limit, we have indeterminate form of a limit. What are these indeterminate form? They are plus infinity minus infinity, infinity over infinity, 0 times infinity, and 0 over 0. These doesn't have or don't have a value. So we need to do something. When we have infinity plus infinity, and for example, 0 times infinity, we do something. We might do expand, or we might do factorize. So if we got these values, we can do expand or factorize. It depends on the function itself. If we have infinity over infinity or 0 over 0, we used to do something which is called factorizing. Okay, so we used to factorize the numerator or the denominator. Then we cross out factors in order to calculate the limit. I will give you an example. So suppose we have x squared minus 49 over x plus 7. And I'm doing the limit when x tends to minus 7. So if we replace above minus 7 squared minus 49 is 0. And minus 7 plus 7 in the denominator is also 0. So 0 over 0 is indeterminate form. So what do I need to do in this case? We used to factorize. I will factorize the numerator. So x squared minus 49 is x minus 7 into x plus 7 over x plus 7. In this case, I will be eliminating the factors, and we have left x minus 7. And now I do the limit. Minus 7 is minus 14. So that's how we solve it when we have a fraction, okay? Let us continue. The derivative of a function. Let us remember together the rules of the derivative. First of all, as a definition, the derivative is the rate of change of a function at a specific point. The rules of derivatives are, if we have a constant, then its derivative is 0. If we have x squared, the derivative is 2x. The rule is itself, if we have x to the power n, the derivative of x to the power n, it's n, we put the power down, n, x, and minus 1. So if we take an, sorry, if we take another example like x to the power 4, its derivative is 4x to the power of 3. Now, what if we have u over v? How do we find its derivative? It's u prime v minus v prime u over v squared. And that's why we calculated the derivative of 1 over x is minus 1 over x squared. Now, what's the derivative of u dot v? So if we have two factors, two expressions, two terms, u dot v, the derivative is u prime v plus v prime u. Okay, now if we have u to the power n, it's like, for example, we have x plus 1 to the power of 5, and we need to find its derivative. It's similar to x to the power n, so it's n u n minus 1, but I need also to multiply it by the derivative of the term itself inside. Let me give an example. So if we have like x squared plus 5 to the power of 7, and I need to calculate this derivative, it's 7x squared plus 5. It's multiplied by the derivative of the term itself, which is 2x. Sorry, this is to the power of 6. Okay, so that's the derivative. We are revising all of these because we need to study a function. At the end, when I finish the continuous, I will remember together all the steps that are needed in order to study the sign of the function. What's the meaning of a continuous function? A continuous function is a function such that a small variation of the argument induces a small variation of the value. Suppose I have a function, okay? It stops here and then it continues like this. This function is discontinuous because at some point the function is not continuous. But how do I calculate it? I have to do the limit of a function when x tends to a plus, means at this point a plus, it should give the same value as the limit when x tends to a minus. It should give the same value as f of a itself. Let us take an example. Function f of x is x plus 1, x less than 2. This is 2 minus. 2x minus 1 when x is greater than 2. So this is 2 plus and f of 2. So limit of the function when x tends to 2 minus, I will take the first one. 2 plus 1 is 3. Limit when x tends to 2 plus, I have to replace here 2. It's also 3. And f of 2, also I replace it in this function. It's also 3. So all of these are equal, then f of x is continuous at 2. Now we're going to revise together all the important concepts when studying a function. These are from the last year. When we want to study the variation of a function, the first thing we have to do is to calculate the limits at open boundaries. We already remember together what's the meaning of limit and how do we do it. Then we need as steps. First, the limit. Okay? Then we do the derivative. Directly after the derivative, I have to do something which is called study the sign of the derivative. So I need to know where's the derivative positive and where's the derivative negative. Why? Because there is a relation between the function and the derivative. If the derivative is positive, then the function is increasing. If the derivative is negative, then the function is decreasing. So that's why it's very important to calculate the derivative. After calculating the derivative, we need to do, this is the derivative, we drew the table of variation. The study sign, it's the derivative equal to 0 to find the root. So I'm going to do this. If we put the derivative equal to 0, I'm going to get two roots, x equals 1 and x equals minus 1. I put them on the table, minus 1 and 1. Okay, this is the derivative. Here we have x minus infinity plus infinity, okay? And I have two roots, okay? Inside the root opposite sign of a, here we have a3, it's positive, so plus, minus, plus. Why do I need the derivative? Because now I can say that the function is increasing, decreasing, then increasing. And that's the relation between the derivative and the function itself. Of course, there are a lot of important concepts that helps me in drawing the function, where I study if it's an even or odd. Sorry, I can find the center of symmetry. I can find the equation of the tangent. All of these help me in drawing the curve at the end of the exercise. But of course, we remember together the important concepts of studying the function itself. So limits, derivative, and study sign, table of variation, and then we can discuss if it's continuous or discontinuous. Regarding the limit, you have to know if I calculated the limit when x tends to infinity and I get a number, you have to know that this number is a horizontal, the equation of this number is a horizontal asymptote. While if I calculated the limit when x tends to a number and I get infinity, that means x equal to this number, I will put it b, sorry, is a vertical asymptote. All of these, they help me in drawing the curve itself, because when drawing the curve, you need to plot the horizontal asymptote and also the vertical asymptote, because they actually tell how the function is going to be.